screen capture my screen as well as record these notes and do a PDF somewhere and put it in a folder, probably in Purdue Mind Workshop or something like that, and give you guys access. That way you can tinker with it later down. Which means since I have a YouTube videos open as well as a Google Hangout and well as a screen capture, my computer might be a little slow, so be a little patient. But yeah, we should be good otherwise. So I guess going over a couple things that we did yesterday to see how much you guys remember. I might do a little survey in the group me, or else I'll just kind of ask you guys. But let's see, what's the first question I want to ask? Is everyone in the group me? Well, I guess you're gonna see the answers to that right there. Oh, no. I guess I'll just ask you up front. So what is meant by digital versus analog? Someone kind of give me a rundown and explain the difference. Don't be too shy. Go for it. Well, I'll let you go, because you guys should already know.
Digital is on and off, analog is on a scale.
Got it. Cool. So what are the important functions within Arduino to do digital things? Let's say you wanted to make an LED blink. Like, how would you go about doing that? Go for it.
So there are the digital pins, which are either fully on or fully off.
Sure.
And then there are the analog pins, which can go between 30 minutes and 0 and 5.
Okay. So let's say I wanted to make an LED blink right now. What's that code sketch? Anyone tell me what's the first thing I want to do? Okay, so that's with the pin mode function. You guys, you don't have to do this by memory. You can refer back to your notes. What does pin mode take? Choose a pin number, so I'll pick 13. Okay, 12. What? Put our output. Which one is it? In or out? Which one? If I want something to blink, output. All right, what else? What do I put in the loop? So I set the pin already, so the pin's now on output. So now I can start writing to it. How do I do that? All right, so digital write, high, digital write, low, with a delay in between so you can actually see it blink. Or else it will move very, very fast so you can't see it.
Can you really not see it at all?
I can try. I've never tried it, but
Yesterday when you did, I think 50 was really fast.
Jay's like 50's nothing, 16 megahertz. Please.
It was really fast, but then I couldn't imagine not seeing it.
I'll give it a go. I've never tried. I'm curious. Why did I do this, dear Lord? There we go. Jay's like, my eyes work at 16 megahertz. No big deal. Oh, it just looks always on. You see the blue? Yeah. I'm actually a little surprised by that. Okay, that's fair. Let's pick off 100. Yeah, milliseconds. What? I didn't have any delay at all. Yeah, Ajay asked what would happen.
I guess that makes sense. If you don't ever write
It just looks like it's always on, which I would have expected to look like it's always off, but I guess that makes sense either way.
Does it, I assume the analog pin is not controlled with modulation,
The analog pin in,
out.
out.
I assume the analog pin out actually has place with the lower voltage.
No, so we talked about multiple things there. The digital pin, the analog pins, the digital pins do pulse width, and they do full 5 volts or 0, and they just change how long it's on. So then you have analog output pins, which are digital and analog converters, and those are separate. Those need to be arranged individually in that scale.
So can the LEDs here take a lower than full input?
Yep. So the LEDs have, I don't know if you guys know this, but forward voltages. So the minimum amount of voltage for it to turn on. Yeah. And so like the scales from red is the lowest, which is like 120, and then green is the highest, blue is the highest, which is around 220. As long as you're past that threshold, it'll turn on. Okay. You're taking 225, you see 225.
So that's just different than
I'm assuming they do as well.
but that's why they need to set it in, because I'm assuming they're like lower voltage to get in.
Right, yeah. I don't know what that slider could be depending on where it could be a bigger resistor. I'm not entirely sure how that mechanism works, but same thing.
So that was like 25 because we got our house has been, but our house was built for 8 as well.
Okay.
So now that they're doing something, so we want to so we
And incandescent, I'm pretty sure it takes 120 volts.
yeah, so like the incandescent, the dimmer just reduces voltage.
Got it.
But for modern LED bulbs, we do a different thing for that. We use voltage modulation.
Got it.
Because I guess they do not have to analog voltage.
So why they chose to use the dimmers that decrease the voltage versus the dimmers that cause PWM? That's a good question. I can't turn these up and look, but you should buy some of the bulbs and look at them. I'm actually curious about that. I'm not entirely sure why that is. Cool deal. Are we following so far? Everybody good? All right, cool. So I guess along with that, with my soliloquy with Buddy, what do we know about pulse width modulation? Who wants to kind of give me a quick explanation of that, apart from Buddy? And please feel free to look at your notes. This isn't like a quiz or anything. Once you see it enough times, you'll get used to it. Go for it. Square root and square wave, yep. So we got our square wave. And let's say we have a cycle, a full cycle time t. And so PWM, pulse width modulation, is just modulating the pulse width. Modulate, ooh, come on. So the length of, so how long it's on versus how long it's off. So let's say that's 50%, so t over 2. Let's say this is 25%. And I guess to give you some keywords here, which I didn't last time. Let's say this is 10%, so it's on for only 1/10 of the time. There are a couple keywords when we talk about pulse width modulation. Ooh, that's weird. What's going on? All right, new page. So I can't do with figuring that out. Oh boy. Well, that's weird. Anyway, the keywords are pulse width, on time, off time, and duty cycle. So duty cycle is just is in percent, and it's just for how long it's on. So if it's on for half the time, we say it has a 50% duty cycle. If it's on for a quarter of the time, we say it has a 25% duty cycle. On time is just how long it's on, so that's generally in seconds. Off time is just how long it's off. That's also in seconds. But typically, the words you'll hear are more likely duty cycles. So someone say, hey, set this at 50% duty cycle, set this at 25% duty cycle, et cetera, et cetera. You should also know the frequency. So the frequency, no one really ever talks about the frequency of the waves so much, but on your, do we know UNO? The frequency of the PWM signal is typically 490 hertz. On the SAMD21 it varies, but I think it's somewhere on the order of 790 hertz. So it's just fast enough so that it looks like you can average the signal over time. I don't know what that deal was. Making sense so far? We good? Cool deal. So think about a couple other things that we talked about. That was more or less it. And then we discussed interrupts a little bit. We talked about specifically hardware interrupts. Better, slightly better. Hardware interrupts. And we talked about them specifically in the context of button inputs. So if you say your button is outputting 0 volts to start off and you press it, so you just have a momentary press. It goes from 0 volts to 5 volts momentarily. And so your interrupt can either trigger on this rising edge, it can trigger on this falling edge, it can trigger on high, or it can also trigger on low. And so the interrupts is basically looking at a change in the pin's state. High to low, low to high, one to the other, et cetera, in different modes you can configure, and that's given by the Arduino's attach interrupt function. Interrupts are really, really handy because, again, if I'm making a smartwatch or if I'm making a pressure monitor for, I don't know, for a blood pressure cuff or whatever, and so the blood pressure cuff is going to send out an interrupt signal in case you exceed a certain pressure, and so it wants to interrupt whatever it is that you're doing because this is an emergency, we need to take care of this now. So it sends out an interrupt signal, the microcontroller stops what it's doing and reads that immediately and does some sort of process to deal with that interrupt. Is that making sense? And so that's a hardware interrupt, and there are also timer interrupts, which we may not get to till next time. I don't know why this is happening, so I'm having a bit of a bug here. A timer interrupt, and that those basically just keep things at a certain time, so you can do like consistent sampling frequencies for different stuff. And so one thing we went over, we kind of glanced over yesterday that I said I would kind of go more in depth today is called transistors. Because I mentioned yesterday, for those of you who have the Arduino Uno or the Arduino Red board, you're okay with simply being able to drive the buzzer directly. So that it has enough output current capability. Remember we talked about you can have digital pins that can write information, but they always have some sort of output current, sink and source. So source means how much current they can provide to the system. Sink how much current they can receive. And that's basically their acting as a ground source. So the Arduino Uno digital pins have a sink and source capability of around 20 milliamps, but the same 21s have a sink and source capability of around 3 to 5 milliamps, sometimes 7. So if you want to drive a load, if you want to power something that takes more than 7 milliamps, more than 5 to be safe, I think you really need it somewhere else with the same 21 chip on Arduino or Red board. Does that make sense? And so if you it's just imagining that your Arduino's digital pin is a battery and needs to power something, it's just a small battery. If you want to power something so much. And so typically, the way to do that, whenever you're dealing with microcontrollers and how to provide higher currents to systems, is to use what's called a transistor. And so you can go into transistors more in ECE 255. And so this isn't, I'm not going to go too much in depth because honestly we spend a third, well, 2/3 to 4/5 of the semester just talking about transistors in 255. I took an equivalent class at Vanderbilt, and we won't go that much in depth, but I'll just kind of give you the Cliff Notes version of them. And so there are two main types of transistors. One are BJTs, which stands for bipolar junction. Man, I wish this thing would write better. Bipolar junction transistor. And then there's a MOSFET, which stands for metal oxide semiconductor field effect transistor. It's FET for short, this field effect transistor. And BJT is already short enough. And so each of these have kind of their own set of benefits. Let's see if I can expand this just a little bit. Full screen. I don't want that button though. I don't want that button. Sorry guys, but OneNote is giving me trouble here. Let me go to something else. So BJT, zoom in. Bipolar junction transistor, MOSFET, metal oxide semiconductor field effect transistor. And so within these two transistor types, you have two subdivisions. You have an N type and a P type. And then you have a ton of other types of FETs. I'll just give you the Cliff Notes version. In general, I like to think of BJTs as current amplifiers. And I like to think of MOSFETs as voltage-controlled current sources. So I guess to be consistent here, we can also call BJTs current-controlled current sources. Fair enough? Sounds reasonable so far? So if you go to the basic schematic of a BJT, now pick the NPN, not the PNP. This one's big. Come on, Wikipedia. Give me a good picture. Can you guys see that well enough? Okay, yeah, that's pretty big. So C stands for collector, B stands for base, and E stands for emitter. And so this is an NPN type transistor. So what happens is current actually flows from the current down to the emitter. And so what happens is you put a small current at the base, and each transistor has a specific current gain. And so the simple equation is the current at the base times the current gain will equal the current from the collector to the emitter. Does that make sense? And so transistors are simplified some more or less as just kind of switches, especially FETs, but BJT as well. So if there's no current flowing to the base, the connector and the collector and the emitter are disconnected, so there's no current flowing to them. So if you imagine, like we talked about the momentary switch, section 2, we talked about it having some pin 1 here, some pin 2 here, and this is your actuator. And so you push it down, you close the connection between 1 and 2, and you allow current to flow. All right, it's similar for this NPN transistor. Collector, base, emitter. So the simplified model is the current through the base is equal to 0. There's an open circuit. The current through the base is equal to some threshold. I forget what the threshold is exactly. It's not equal to 0. And IC is equal to, current gain is usually HFE in the data sheet, or beta times IB. All right, somebody asked me one question. Go for it. I don't remember what I said.
Ask me a question.
Let's look it up. I'm not sure. What does HFE mean, transistor? When I was taught in my class, hybrid parameter Ford, current gain common emitter. I don't know who came up with that name, but that's what that means apparently. Yeah, when I was taught in school, we use the term beta, but when I started looking at data sheets, I started seeing HFE, and I'll actually show you what that looks like. So I'll just look up a random NPN transistor, 2N222A. Yeah, they have stupid names, but that's just kind of how things work. This is one of the incredibly common ones, as in like everybody makes them. So when you look up the data sheet, you'll see that from multiple different manufacturers. I wasn't familiar with HFE until I started doing this stuff. And so if you scroll through the data sheet, it's a unitless number, so I usually just scroll till I find something here. So here we go. HFE, DC current gain. And it varies based on your different set of parameters. So you can see that it's kind of around 35 to 100. If you're at super low collector currents, you get a really low gain. If you get up higher to where we'll probably be around, which is about 10 milliamps, 10 volts would probably be around the 75 area. But it's a nonlinear parameter. Make sense? So also get used to looking at data sheets. As you can see, obsolete product. So when you buy these transistors from Amazon, they just, they pick all the ones that no one cares about anymore, which is why they can sell them dirt cheap and sell them from a bunch of Chinese manufacturers. So this is a pretty obsolete type transistor, but yeah, I have a ton of them and they're cheap and I got them for free essentially. Go for it. This one? Oh, this one, small signal current gain. So this is if you're putting, this is a DC. So if you're putting a direct current, this is an AC signal. So if you have a time varying signal. Small signal. That's what that means in electronics. Small signal, and it also puts a frequency parameter. Yeah. And so what it's saying is the difference between. There's no one on the hang outside. I'll just put a load here. Resistor. Also, you also always want a resistor at the base. So you have an AC current versus let's say DC current. If you take ECE255, you go into painstaking detail on transistors, but honestly, for what I do, this is honestly pretty good enough. That sound good? So the way we actually want to drive motors, I'll try this again, so I do want to store. At the very least, I can take pictures of them, I guess. Hello there. Yeah, come on in. Orlando, nice to meet you. This is going to drive me nuts. Why are you doing this to me? So we're going to hook this up to our buzzer. And I haven't given you guys the buzzers yet, but essentially they have two leads. One of them can be longer than the other or shorter than the other, but somewhere on the buzzer it's going to have a plus on one side. That's the anodes, that's the positive side. And what you're going to want to do is you're going to connect that buzzer, and I'm going to use the symbol for a piezo element here. You're going to connect that buzzer to 5 volts, or actually 3.3 if you're using the same B21. Actually, 5 volts is fine. 5 volts, 5 USB, or VUSB, depending on which type of Arduino you're going to use. We're going to connect that to our transistor. And then the emitter is going to be grounded. And then you always want to put a base resistor. So remember I said before that the amount of current that flows through the collector is going to be equal to the base current times the current gain. So you want a small resistor here, or whatever size resistor here, to set the base current. If you don't set the base current, you can do a lot of bad things. So make sure you always have a resistor there. And then this is going to go to your digital pin on your Arduino, digital I/O, I guess. And then you can do various sorts of pulse width modulation to get sound through your speaker. Go for it. So for the piezos will generally have a current rating. I bought these ones off Amazon, so I have no idea what they are. I think they're probably on the order of 20 milliamps or 80 milliamps. So the current gain for these transistors is going to be on the order of 70. So you can pick the resistor based off of that. Make sense? Cool. All right, so that's BJT transistors in a nutshell. And these are NPN. And that's based on the polarity of the diode. I won't go into too much detail on that, at least not yet. But these are NPN transistors. Do some of you have buzzers already? No? None of you have buzzers? You need this? Buzzers on the first. Cool. You want to move up here? Oh, yeah. Look at the transistor couldn't tell me what number it is, because some of them are, not all of them are the same. It's hard to read because it's in gray, so you just have to tilt it to the light. Yeah, yeah. What number is it? Huh? 4.
Yeah, that one too.
Got it. Okay. Same one you have, Jenna? Same one you have? Got it. Did you get one? Yeah, yeah. You're just working with K. Okay. So these 2N22A, because these are old and no one cares about them anymore, the documentation is really poor. Does it have an A at the end? So you guys see this pinout? Is it good enough? So if you have the flat side facing you, the emitter is to your left. And so what you want to do is hook it up like so. I'm going to use a symbol for a piezo element again. We want to connect this to USB. And so I know this here is your collector. And this is ground. And so you want to ground your emitter. And then your base, you're going to connect the resistor. And then this goes to some digital I/O. A couple other nuances to set this base resistor. So your digital I/O pin, at least on the SAN-D21s, are going to give you 3.3 volts. The voltage at your base is going to be 0.6 volts. So you use an Ohm's law there to set your current, and then you determine what it is. So remember the current through this, IC, through the IB times, we can say around 75. Challenge doesn't set some algebra. Wolfram Alpha is your friend. Hello there. What's your name again? What's your name again? Yeah. 11. So have you ever used Arduino before? Got it. So I'll hook you up then. So we're all using this board. I should have more USB cables. Oh, and I guess you want IC to be 20 milliamps or 80. I don't remember what these numbers are. I think it's 20. That should be more than a lot of them. Like, you want a Sandy 21, buddy? You want a Sandy 21? Yeah, is that the one we'll be using? For those of the people who attend, I usually give it to you and then you just pay me back. So you don't. I don't think I've had any of you buy anything by yourself, did I? I don't think so. No. You want to do that or no? Yeah, I already have all of them. That's very important. The total price of the whole thing. Got it. 549 each. Yeah, I was putting the group chat. Yeah. No, it's official. Well, it's a Spark Fun brand. Hmm. I said go to the workshop outline. Go to session 3, and it'll point you to a guide. How to install all that stuff. So this is basically similar to the Arduino Zero. It's just Spark Fun's board. Hmm? Cool. It's on the board. It's written on the board. Should be right above 3.3. Well, right below 3.3.
Oh yeah, that's right. It's good.
Hey, buddy, want to do me a favor?
Yeah.
You can take care with me. Solder the headers on these Arduinos. The one that you have and this one.
So have you ever successfully one
What do you mean? That's
still in, so like, I was afraid, like, it was so good, everything's so
Wait. So are you going to the lab?
Oh, yeah.
I left mine. Yeah, that was just.
So I wanted to know,
I go home Purdue sometimes.
oh, that's just me.
Do you have a portable solder guy? I don't mess up. Portable solder?
Are there some in lab?
Yeah, you can use the one in lab if you want.
Yeah, I just can use those. They're alright. For
Okay,
the
that's Yeah, you're gonna need some cutters though.
the vacuum desoldering, I don't know what it's called.
Yeah.
Yeah, push it down. Is the metal piece supposed to be outside of the tube or inside?
With metal piece.
So like,
There's a plunger.
yeah, is the tip of the metal rod that comes out? Yeah, so like when you fully
This part,
when you fully compress it down, is that rod supposed to come out?
the other end.
Yeah.
No.
That's interesting. There were two in the lab, and one of them the rod came out, the other one the rod didn't come out.
Oh, it shouldn't come out. Yeah, push it back in there.
You get both people with that one?
Okay, so I guess while you guys are doing that, I'll give her a quick overview of Arduino. So this is called the Arduino IDE. IDE stands for Integrated Development Environment, and it's just where you do all the code. So this is called the sketch. It's just the name for the code of Arduino, and the end in .eno. And so an Arduino code has two main parts. I hate that they do this, it drives me nuts. We have a void setup. So setup only runs once. And then you have a void loop. Make sense? So if I put code here, so if I said some for loop, have you done coding at all before? C in Java? Solid. So if I had some for loop, I don't know. Yeah. What do I want to do? What do I want to do? So you're familiar with global variables, right? You familiar with global variables? Variables. Yep. And so if I just define a variable here, does this make sense? So what it'll do is it'll run through this for loop, and at the end of the for loop, it'll go back again to the start of the loop and do it all over again. So this section just runs indefinitely. So if I wanted to make an LED blink, what I'll do is I'll write some code to say turn LED on. Then I'll write some code to say turn LED off. And then that will just run indefinitely. Yep. Exactly. So that prevents me from having to do something like this, right? Like I don't have to do that because it's already in a loop. And so that's saying you don't have to do I don't have to do that either. Make sense? Cool. So there are a couple other nuances. Well, that's mainly it, to be honest, just a kind of different environment. And then you kind of start to learn different functions. So for example, if I wanted to blink an LED, there's a special function I need to declare that's called pin mode. And so pin mode takes two parameters. You familiar with the term parameters? Parameters, yeah. So if I have a function, this is what they always use in intro classes. Void foo, right? Int I, maybe int p, int b. And so void is the return type, right? Foo is the function name. P and b are the parameters. There. Do we follow? And then we have the function body inside the curly braces. Good? So in this case, pin mode takes two parameters, one being the pin number. So if you look at the Arduino I gave you, you'll notice that there's some things here on each side. Starting from this side, it goes from like 0 up to 13, right? And so those are pins. And these specifically are digital pins, so they either turn on fully or they're turned off fully. And if you look to the right, well, if you're looking at it this way, it'd be to your left. Down to your bottom left, you see analog in. And it's A0, A1, A2, A3, A4, and A5. Those are called analog inputs. So they take time-varying signals like sinusoids. So we have analog. We do something like this, infinity variable, or something like biomedical, or something like that. Or we have digital, which are either on or off. Makes sense so far? So your digital pins give you this. Your analog pins can read information like this. And so if you want to try to make an LED blink, we can just use digital pins, for example. And to set up digital pins, we first use a function called pin mode. So digital pins can either output information or they can read in information. And so reading in, we'd want to use input, pin mode input. But since we want to make an LED blink, instead of declaring them as input, we'll declare them as an output instead. If you're reading in digital information, like a button, for example, if someone's pushing the button, you want to detect whether or not the button's pressed. You guys are like, you have questions. What's up? No? Just listening intently? Go for it. What's your resistor value? That sounds about right. 3.3 volts minus 0.6 volts divided by 10 kilo ohms times the gain, which is about 75. That gives you around 20 milliamps. Yeah. Sound good? Yeah. What do I want to say now? All right, whenever you got that wire, go ahead and plug in the buffer. Yeah, the thing that looks like that. So that's the symbol for a piezo crystal. So these are piezo buffers. I kind of go back and forth with what I want to use, to be honest. And so notice the positive side of the buzzer is connected to the USB, and the yep, it should be the long one. Or sometimes they have their labeled. Sometimes they have a plus sign labeled on them. So not always. Yeah, that's fine. You don't think so. You can start making beautiful music. And so we talked about using analog rights, but whenever you want to change the frequency of your tone, you use the tone function, and that takes a pin number and then a frequency F. That way you can make some beautiful music. And so your next task, once you got that set up, is actually make Marietta a lamp. What to do is you're going to use buttons to trigger each of the trigger and interrupt each of the different notes. And you can play
There's three of us, right? So what happens if we only get two?
for these, you have more than for the red board, not red board, sorry. The,
Oh, Sam was talking about
and so what I'm doing is like you don't start learning this stuff until you start having to use them for something. The problem is maybe they'll use them so you start thinking through how you go about designing something. So we're kind of going to practice that. So off of this, it's relatively easy, and then as we progress, it's going to be detect this heartbeat signal, give you heart rate, give you heart rate variability. So basically, what's the resistor? Most of those are right. You gotta give it the right code and one right or whatever. change the delay to change the speed of it blinking. So the easy way to start off with your little thing, pin number, I don't know what pin you put this on, but let's say 6, as long as it's just PWM enabled. And then you can essentially just do pin mode, and then you always want to declare it as an output, and then you can do analog write pin, and give it some number. Remember we talked about this being the duty cycle, so this means 50% duty cycle. And you can run that and you should start hearing the buzzer going off. And then you can make it, you can even upload the blink code to the buzzer. So you make it beep, 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 and then you can also do the fade, so you can hear it, and back and forth. So go ahead and play around with that a little bit, and I'll be back.
Corey even talked about it today. Like, hey, here's the board for 290. Let's start on stage. He told me, so I think so he said, portfolio. Portfolio is like kind of linking. So he told me, he said, okay, so I don't know, but I thought all this was the same. I thought it was just like, no, so I thought so what's the email about portfolio is just like a new more UI design into it. And then I thought it was just like I just
just taking these from the previous slide, from the students who left there. So you can follow up with these if you want to. Or you can tell them I just keep it to the go for it. Big and buzz, guys. Come on, I'm waiting. Then you gotta be Mary Ann Little Lamb.
The first day after you give us boxes, I received yeah, we have really good travel.
That's funny. Remove seal after. Maybe it's you mean you got wind now? We talked about analog right. So wind is just binary, it turns on fully, or it turns off fully. Sometimes you want to start it. Because digital, that's what we're going to do. Fully on or fully off. What we do is kind of change. Hey, did anyone ever come on? No one's here today. Whenever we want to go in between with digital pins, we use what's called pulse width modulation. God, why is it doing this to me? Fair enough. I'm going to take pictures of this. That way I can put it in the files. Hey, there it is. It said the digital. You just have to plug it off. It runs indefinitely, remember? So now I try using the tone function instead of analog right to get different frequencies. So you said digital is either fully on or fully off. Right? In this case, for the same B21, on is 3.3 volts, and off is 0 volts. So what we do is we actually just change how long it's on versus how long it's off. And that's called EWM, or pulse width modulation. So in this case, if I have a cycle that's t long, so time t, and then let's say it's on for a third of the time, t divided by 3, and off for the other 2/3 of the time, right? We say that is 33% duty cycle. Sound good? And so then if I change it up a little bit, and I say it's on for 10% of the time, and off for 9/10 of the time, we say that's 10% duty cycle. And so if we hook this up to an LED, for example, so the LED is our load, what the LED sees, if we do this fast enough, it sees an average. So if our full voltage is 3.3 volts, and we have a 10% duty cycle, the LED sees an average current. Let's say voltage of 0.33 volts, for example. Does that make sense? It's not the average current through the LED is going to be 10%, but not exactly the average voltage. But that's so in the case of 33% duty cycle, what will the LED see? So let's do 33 and a third. That's a third. 1.1. Sound good? And so the example in Arduino to do that is called fade. So if you go to File, Examples, and look for fade, you should see it. And I'll give you an LED to try it out. Come again?
It's gonna buzz the entire
Is this sticker on it? Is this sticker on it?
Sticker bucket.
Yeah. What's your thought? It is for Good my best. Once it's bad, then
Never tested it.
Your side chapter is just a set of these. Here, call it.
Okay, so this is what second of it.
Oh, why is that like that?
So there's no power injector.
So LED solar.
Come on, make some beautiful music. Get some different frequencies in there.
You can find online, they have a guide, black values, what not,
Oh no, so you can see they're all legal. So I
I'll actually take this class. Remember, switch in, you said. Otherwise, I would take it.
You guys got some buzzing? You guys got some music playing? Yeah, fade will give you analog rights, so that'll change the volume. Out of the box, out of the box. Take. Change now. Yeah. Mine's better. Sour. That's what her voice is hoarse. I don't know what I did wrong. Alright, that's your goal. You gotta beat that. The cold never bothered me anyway. Do. Tra la 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 la. Your job's to do Marietta Little Land. If I beat you, everyone buys me Fiesta. Whoa. Alright, you are not allowed to come to this workshop anymore.
You know where Red Label is? Fresh. It's delicious.
Why would you want those? That's why they're giving them away.
I don't know, I just happen to oh no, all the I
And
don't
then
know.
they'll make cookies.
I don't know. But like all the medical fees is just like so sad.
Did anyone jump in on the Hangouts? Bummer.
Yeah.
Oh crap! How long you been here? Dude, why don't you say something?
I have my
Oh, like I had no idea anyone was there. Hold on, like, are you good? You need me to go over something? So, I'm sorry, I had no idea. I kept looking back and like, huh?
I said you're alright.
Okay, what have you been doing?
I've been trying to mess around with my buzzer.
Say again.
I've been trying to mess around with the buzzer.
Got it. What you got?
I don't think I have any transistors unless.
That's fine. You have the Uno though, right?
Yeah,
You can hook it up directly to a digital pin. You're fine.
that's what I was thinking. By the way, is an op-amp technically a transistor?
An op-amp is made up of transistors.
Okay.
But for this, if I put a buzzer, I put a resistor like a 57 ohm or so in series with my buzzer, but you're probably fine. I've hooked it up directly to the Arduino pin plenty of times, so you're fine.
And with a buzzer, does it matter, like, of the two legs, which one's which, going to ground or?
Yeah, so typically it'll have a plus sign on one side of the buzzer, or one leg will be longer than the other.
Okay.
Dude, I'm so sorry. I kept looking back, being like,
Okay.
no one's here.
That one icon was you.
I thought so too. I was like, I noticed it switched views, but I was like, maybe it's just showing me twice or something. I'm so sorry. All right, so I'll take pictures of everything I wrote on the board, and I'll put it together in a PDF. OneNote has not been working well with me today, so I kind of have to write on the board a little bit.
Alright.
But the buzzer is pretty straightforward. You just hook it up directly to a digital pin, and I'm sharing my screen now, so there's an example, right up here. But just look on the buzzer. Either one leg will be longer than the other, or there's a small plus sign written somewhere, or both.
But I thought, Dr. Martinez was you recommended putting a 1 kilo resistor.
I agree. Yeah, I think.
That would produce the voltage between your digital lighting and
Yeah,
that would produce volume, so it's not
blaring. What size resistors do you have?
Are you talking to me?
Huh?
Are you talking to me?
Yeah.
Oh, let's see. 100K.
What else? That's too big.
I don't know what these ones are.
I'm sure.
I think these are 5K.
One sec. 5K is usually atypical. Read the color to me.
Okay, I'm not sure if I'm reading it.
That's
right
fine.
to left or left to right.
You want to put your video on and just show it to me?
I do not have a webcam on my desktop, unfortunately.
That's fine. You just read me the color.
Okay.
In either direction's fine. I'll figure it out.
Okay. Red, orange, brown, gold.
That's a fairly atypical. You sure it's not red, brown?
Yeah, I think it is. Red,
Okay,
red.
so that's 220 ohms. And you can put that in series with your buzzer to limit the current so the sound isn't as just blaring. And it's a little safer too for the digital pin.
Okay.
All right, so the next task is to make a little piano. So you know how to do interrupts, you know how to play tones. So put them all together. You have several buttons. Put them on to make different tones. So you need more buttons.
I think there are like 2 buttons, and I need 3 buttons.
So you have the same. So you can have 4. You can have run your interrupts on the same one. Try using the hardware interrupts.
Everything but one thing, right? Except for 4.
Try using the hardware interrupts and also tone to generate different frequencies on the buzzers.
I'll probably try coordinating it.
So that's the future of interrupts first.
So I'll probably check coordinating it so like if I get a noise about what if it's like tone for above one threshold or not or something.
But dude, this is the engineering part. You got a problem, and you got to think of a way to how to solve it. That's sense.
Is that a machine or not?
And then you started the PCB design tutorial.
Oh yeah, I finished it. So you need this in my class. What class do you want?
The board is .prd. So eventually, I'd like to start putting some of these circuits on circuit boards. So like if you have anything to review, so you start putting them on. But if you go through the tutorials I sent you,
It's just Orlando showing people how to do like
yeah, you gotta go through what's
something like that. But I'm showing him my PH circuit because it makes no sense.
Do you hear that, Damon, about the PCB tutorials?
What is that?
So we're trying to record different.
Have you started the PCB design tutorials yet?
These two.
I've looked at them. What were you wanting us to do exactly though?
This only works.
So in one of them, I think it's called Learning Eagle.
I'm recopying.
So this file here, it tells you to design the Blinky circuit, and it gives you a link to the Blinky circuit.
Oh, okay.
So you basically want to design that. So you'll have something that looks like this. I'll show you a student's that did one before, if my computer will stop being as slow. Designs, orientation. You know Ali Abusala?
Yeah.
Yeah, so this is his circuit.
So okay.
So do you want
This-
board and
this
schematic?
stage
Yep.
is holding-
So the schematic will walk you through like making the circuit diagram. His got a little messed up, unfortunately. And then the board walks you through like making the actual physical board. And so this is his board here. Can you see my screen?
It doesn't work.
Yeah.
And what that translates to is this. When we actually get it printed. Here. And so this is his complete design. And the blinking just looks kind of erratic just because my computer's slow because I got a ton of stuff running.
Are you guys able to print on campus?
No, we'll actually send this off to a company, so it gives you a small guideline of like how big to make the boards. Because this company is $5 per square inch, so I think all these board cost like $5 or something, with free shipping. But we can do some printing on campus. There's BIDC, Bechtel Innovation Center, so it does do. They mill the boards. Personally, I don't really like milled boards, so I just print them. So I just send them off to get printed. But you know, it's kind of up to you. Yeah, but this we send it off to a company to get it printed.
Okay.
I don't know who this is. So once you watch the videos in setting up Eagle, and also PCB designing.
Yeah, I've got Eagle set up, but I haven't started on making any
Cool.
that one.
All right, sounds good. So I'm actually using an Arduino Uno like you are, Damon.
Okay. Yeah, I got it working. I used the melody sketch.
Oh yeah, cool. I had a bit of issue yesterday with both buttons being recognized at the same time, and I wasn't sure what that was. Oopsies. Alright, better. Yeah, it's actually really slow. I should probably actually save. I hate the way they set up their brackets. Hey, Damon.
Yeah.
So you want to try our little piano challenge?
I don't have the buttons, but
No buttons?
yeah.
You can probably... Go ahead.
I was doing it with one of those jumper cables.
Okay, yeah, that'll work too. And so do you remember our talk with... Were you here yesterday when we talked about interrupts?
Yeah.
So you understand this whole attach interrupt thing?
I used it yesterday.
Okay, cool. So like for instance, for button 1, you can essentially just have like tone 1, whichever frequency note you want. Yeah, I'd put C sharp, I guess. I don't know anything about music. Or play tone 2, and that could be B flat. What's B flat? What's the symbol for B flat? And so that's kind of about how I imagine this going. So for you, with the Arduino Uno, you only have 2 interrupts, and they're on pins 2 and 3. And then you only have a couple pins with PWM, so that will be the pin that you'll attach to your buzzer. So if I can give you an example, I'll probably just snap a picture of this and put it in the GroupMe actually. This would be an example setup if you do have some buttons. I ignore the circuit that's like right above this. This is an example circuit with me attaching the buttons and then me attaching the buzzer as well.
Okay.
But in your case, I guess you'll be using the jumper wire. So let me do a quick one. I can probably do tone. I don't know what frequencies are. Do 6. I don't know what B flat versus C sharp is. Is Langer considered father teacher engineer? Monday we'll do a little bit more. I want to see you guys again by then. And then the day after we start the topic. Really? How many copies? 2. I think 2 classes, but it's like 5 copies. That's up there. We're trying to get Latin. One more thing, we can do serial read. Let me catch up with Damon real quick. All right, Damon, you gonna try your hand at the piano?
Possibly. I was just making sure I understand that whole circuit you put up on the grouping.
Okay, so this is just so this is basically the buzzer circuit. That's just and I added a resistor in series with it and a button circuit.
Yeah, I was curious about the button. So does it have to have like two inputs?
So the way I did the button, I kind of do my button circuits a little differently. I add an extra resistor as well as a capacitor, and that's for a couple reasons I haven't really talked about yet. But you're probably good enough just doing, this one here. Like I showed yesterday.
Okay.
Which one is? Well, let me use split screen. So that's. So the next thing is brackets. So because you're using that Arduino board, it does this somewhat a little more special than the other one I have. And so on. All right, so we got our setup, right? So inside the setup, we're gonna use a different function called serial. Well, this is the object. Serial USB dot begin 9600. So the Arduino communicates to the computer using what's called serial communication. And so these Arduinos that I gave you have kind of a special communication protocol. So because they're native USB, they can talk to the computer directly. So we use the serial USB object as opposed to the serial object. Well, it's not really the same. And then begin just means initialize communication. And then 9600 is the communication speed. That's basically 9600 bits per second. It's technically 9600 bauds per second, but I'll just say bits for this. And so now we can actually talk to the computer through the Arduino. And so inside loop, let's just write serial USB println. So println is the same as like Java and C. Everyone uses println. Hello world. Oopsies. And let's put a small delay in there so it doesn't, just take over our screen. Can you see that okay? Okay. So go ahead and load that up to your Arduino. And then when it's finished uploading, you gotta wait till it's finished uploading. you can press this little icon here, so that opens up the serial monitor. But wait till it's finished uploading, or it'll get a little crazy. So each of those, so letters are represented as basically binary. So you send the binary. Have you ever heard the term ASCII before? ASCII. Yeah. So each letter has its really ASCII number. So it's some number from 0 to 1. So that represents sends out there's serial one from the other. Like this is serial.
Aircraft.
Huh?
Aircraft.
Nice. Yeah, Eric has to go, so.
Yeah.
What did you say was wrong?
Because so we were trying something and it worked perfectly fine on, and so we did two things. I'm making a pH sensor, and what we figured, ours needs to be inverted versus a regular one. So we turned inverting, non-inverting copy into inverting copy.
Sure.
The first mistake. Second mistake is we tried that game at the same time. So the problem is that there are input units very low.
Right.
So we were using it when we were testing it with a function generator.
Mm-hmm.
And we were saying function generator can supply as much current as we want.
Really?
We didn't use it
Got it.
to whether it was working or not. However, when we actually connected it to the real sensor, it's not supplying current. It's
Sure.
just a small low voltage.
Got it. So you okay.
So that it was crazy. We were trying to draw.
Cool deal. All right. Well, let me know how it turns out.
Did I spent 3 days?
Mm-hmm.
You're like, why doesn't it work?
This is what you're publishing on, right? Did you submit the paper already? Congratulations. Which journal? Oh. I thought it was your PH stuff. You submitted your PH stuff to epilepsy paper? That seems kind of weird.
It is. It is weird. Okay, so why do I need to do Arduino?
What?
You know, do something fancy with the
Yeah,
Arduino.
so do you see the workshop outline? You know that document?
I'll look.
Yeah, so in there, the section 3 has saying 21 stuff. Did it work?
Bye, Orlando.
Yeah, you just print it all over. And actually, with these, what's that? With these microcontrollers, what do you want? So this control won't run until you hold it. You won't let us do this. So the Arduino is constantly setting it. Yep. So the monitor is being installed. Yeah, I know that. No problem. You You coming back on Monday? Solid. The buttons, yeah. So with these though, I haven't explained. Did you catch the explanation of transistors? Not quite. So you're going to have to use a transistor with this. Hmm? Yeah, I can send you some. Not a problem. And so, hope to see you on Monday. We're going to do some more Arduino stuff, and then we're going to talk about op-amps. Eventually, we're going to build a pulse sensor and a heart rate monitor. It's a very hallmark biomedical project. Hmm? Yeah, you already have the part. But yeah, the buttons are on me because they're kind of cheap anyway, so I'll buy them in the hundreds. I think I did. No? Got it. I thought I sent, didn't I send you an email? What's your phone number? Well, I should probably not screen capture this part. Hold on. Alright, you good, Damon? He already left. Alright, well, we're good there.